Hi everyone. In this lecture video, we will be going to talk about the third most common cost segregation technique, which is the least squares method. The objective of this lecture video is to define and understand the concept and the formulas of least squares method and to solve the illustrative example presented in this slide. The least squares method extends the regression line to the other quadrants in the holistic quadrant analysis. By doing so, additional two formulas are derived to be used in determining the values of A and B. A is the constant or the point of intercept, and B is the variable cost rate or the slope. The complete formulas used in the least squares method are as follows. We have here three equations. For you to better memorize this one is that since our first line of regression here is y is equal to a plus bx, then we have to understand that there will be a series of points of data that we will going to work out here. So for example, we have here point data 1 to 10. So that will be our data points here. So that's why if we're going to use y is equal to a plus bx to all of the 10 data points, then there will be a shortcut on this one. Total cost will going to be dependent on the values of a and bx. Remember that within the relevant range, the total fixed cost here will always be constant. The total fixed cost from one data point to another data point, for as long as it is within the relevant range, that will be equal to each other. So for example, you are working out with 10 data points, then you have to multiply that total fixed cost for a specific month by 10 to be able to get the whole total for the 10 data points. Okay, so that's why we have here the formula for NA. Next is we have here B summation of X. Then remember, in the scatter graph method and in the cost concept lecture discussion, that the variable cost rate or the unit variable cost at any data points, for as long as it is within the relevant range, it is constant. So that's why B here will still remains the same, and we will going to have the summation of X for all of the data points or for all X values. Let's try to prove that B multiplied by the summation of X is correct. All we have here, the X sub 1 is equal to 5, X sub 2 is equal to 10, X sub 3 is equal to 8. If you're going to multiply it by a constant B, okay, for example, our constant B here for simplicity purposes is 2. Okay, so 5 times 2, 10. 10 times 2 is 20, then 8 times 2 is 16. Okay? If we're going to add it up, so 20, 30, and 46. Okay? So that is the long method that we should be able to use. But the shortcut here is to get the summation of this x. Okay? To get the summation of this portion. So we have here 5 plus 10 plus 8. That will give us 23. That is the summation of x multiplied by our constant of 2. That will give us 46 as well. So that is the reason behind how did we arrive with the equation 2. Now for the equation 3, we are going to get the relationship between the x variable and the y variable, or we're going to get the relationship of the units and the total cost here. That's why in the equation 3, we are adding up the value of x. Then we have here x squared. For simplicity purposes, so a na bex and xe exa bex squared. So that's how I personally memorize this equation 2 and equation. If you're going to take the CPA board exam, or if you're going to have your quizzes here, then it's very handy to memorize equation 2 and 3, and you should be able to analyze and you should be able to understand how did we arrive with this equation 2 and 3, and that is all from equation number 1. Let's try to have this kind of example. The total mixed cost of ABC company for the first 7 months of the year 20x1 are as follow. So we have here the data points from January 1 to July. Then we should be able to get now the formulas here. So to start, we have here the value of n, which is already provided 7 months. So n is equal to 7. Then let's try to sum all of the value of the x here, total, which is the summation, 4 plus 7 plus 5 plus 2 plus 3 plus 6 plus 8, that will give you 35. Then for the total column of y, 22,000 plus 30,000 plus 25,000 plus 15,000 plus 21,500 plus 29,000 plus 36,000, that should give us 178,500. Then for the next two column, we have to multiply the value of x to the value of y. So 22,000 multiplied by 4, that will give us 88,000. 30 multiplied by 7, that will give us 210,000. 25,000 multiplied by 5, 125,000. 15,000 multiplied by 2, 30,000. 21,500 multiplied by 3, that will give us 64,500. Then 29,000 multiplied by 6, 174,000. Then lastly, 36,000 multiplied by 8, that should give us 288,000. Then let's try to sum up all of the value of xy. That will give us 979,500,000 pesos. So now let's try to solve for the last column here, which is x squared. So that's basically raising the column x to the power of 2. So 4 times 4 is 16. 7 times 7, we will have here 49. 5 times 5, 25. 2 times 2, 4. 3 times 3, 9. 6 times 6, 36. And lastly, 8 times 8, 64. So let's try to add up all of this. That will give us 203. Now let's plot this one to our equation number 2 and equation number 3. Equation number 1, that is summation of y is equal to NA plus BX. Equation number 2, that will be summation of xy is equal to summation of xa plus b summation x squared. Let's try to plot the given here. The summation of y here is 178,500 is equal to the value of n here is 7, a here is not yet given, plus the value of b is not yet given, but the summation of x is 35. So 35b, let's plot equation number 2. Oops, correction, should be equation 2 and 3. Okay? So for the equation number 3, let's try to plot the summation of x and y, and that is 979,500 is equal to the summation of x here, which is 35a, plus the summation of x squared, 203b. In this case, the two equation will going to imply what will be the relationship of equation number 2 and equation number 3. And to show the relationship between equation 2 and 3, we should be able to get at least one same value for the constant. It can be the point of intercept or letter A, or it can be the slope or letter B. In this case, we will going to get first the value of B. By doing this one, we have to use the elimination method. Since our goal here is to retain the value of B, therefore we should be able to eliminate A. Then our A here for the equation 2 is positive 7A, positive 35. Then we have to come up with a specific number wherein if we're going to add the equation 2A and the equation 3a, that will be equal to 0. Therefore, we have to multiply by negative 5. How did I arrive with the negative 5? Because that will be 35 divided by 7. So that is the easiest way that you can get the multiplier for this elimination method. Then our equation 2 here will be multiplied now by negative 5. Update this one. This will now become negative 175b. So let's try to copy once again the equation number 3. That will be 979,500 is equal to 35a plus 203b. Then we should be able now to eliminate the value of a. 979,500 less 892,500, that will give us 87,000. The value of a here will now be eliminated. Then 203b less 175b here, 28b. Therefore, our answer for this one is, that is 3,107.14. If we're going to round it off, B is equal to 3,107. To answer the first requirement, that is 3,107. Meaning to say that for every shipment, the variable cost is equal to 3,107. Now let's try to look for the value of the total fixed cost. One of the common mistake that you will going to do here is you're going to use the total cost. Okay? So kindly take note that the only equation that we will going to use here are the equations 1, 2, and 3. In this case, we have to use the equation number, and that will be 178,500 is equal to 7a plus 35 multiplied by 3,107. So 178,500 is equal to 75a plus 108,745. Meaning to say, our total variable cost is 108,745. Then let's move the 108,745 to the other side of the equation. 178,500 less 108,745 is equal to 7a. That will give us 69,755. The value of a here is 9,965. To answer the requirement, the total fixed cost is 9,965. Let us try to prove that the variable cost rate amounting to 3,107 and the total fixed cost amounting to 9,965 is accurate. Then let's try to get any of these data points, but I will choose the month of January. We have to get the total cost of 22,000. Let's use the equation 1, which is y is equal to a plus bx. Our a here, which is the total fixed cost, 9,965. Then we have to get the product of 4 multiplied by 3,107. Our total fixed cost here is 9,965 plus the total variable cost of 12,428. Then let's add it up. The total cost here should be 22,393, which is somehow closer to 22,000 pesos. Then let's try one more data points. Let's try the June. So y is equal to a plus bx. The value of a here is 9,965 plus 6 multiplied by 3,107. Our total variable cost here is 6 multiplied by 3,107, 18,642. Then let's add it up with the total fixed cost of 9,965. That is equal to 28,607, or approximately it is equal to 29,000 pesos. So basically, we can now have a confidence that we have computed accurately the value of the variable cost rate and the total fixed cost. That's the end of our lecture video for the least squares method. thank you all for watching.